Assalamualaikum. My name is Muhammad Karis bin Muhammad Hamka and my metric number is 224208. Today I'll be presenting my microprocessor assignment 1 on debugging average 4 ASM by using NASM. Right, first of all, we'll be loading up our file, which is average 4 ASM, and we'll be start building it and start to debugging this by pressing F5, or you can just use the tab over here. And we'll be beginning by putting the memory and into this memory slot by adding a variable, which is data by word, and using hexadecimal with an array size of 4, and another variable which is result by using hexadecimal word with the size of 1. And you can see on the right side we will see a checking our registers over here, and we'll be starting to debug by pressing step over, which is F10. So I'll be using this rather than using the tab over here. So we'll be starting our debugging by pressing F10, and first of all it will check the register, and first of all we'll be seeing the EBP and ESP as a reference point reference of a local variable stored, which is the value of the EBP but will never change. And first of all, then we'll be pressing F10, which is step over to subtract EAX and EAX to clear the register AX over here. So we'll press A10, F10. Now the EX register will become 0. And first of all, we'll be setting our variables over here. So now we need to set EX as a counter to 4. So we print F10, and then we'll be setting ESI to offset to 8. Basically, we're setting ESI to 8. As we can see over here, EX has become 4. And if you press F10, where is ESI over here? And there you go, it become 8. So now we'll be beginning our loop. So first of all, we will decrement SR by 1 2 times. So basically we'll be subtracting ESI to 1, like subtracting it to 1, subtracting it by 1, yeah, 2 times. So press F10, and as you can see, ESI becomes 7 because 8 minus 1 is 7, and press it again, it becomes 6. Now we'll be adding a number to register AX over here, which is we'll be adding the number ESI. Now if we press F10, as you can see, it added a number which is 16,384, thus finishing our first loop. As you can see, we have set our loop to counter to 4, which means we need to loop this array, I think it's array, to 4 times. So will be until Cx equals to 0. So we'll be looping this, thus changing the value of Ax. Minus 1, and it becomes 4. Now loop the label. Now Ax has become 28,672, and our counter has become 3. And now our counter has become 2. Again with the loop, I'll be pressing AX until our loop has become a counter of 1, which AX has become the value of 36,864. Thus, ending our decrement of ESI to 0 as we have subtracted by 1, and adding a number to our register thus become 40,960. Thus, ending our loop as we'll be subtracting ECX to 0. Thus, ending our loop. Now, we'll be at the end of our result. So, now we need to clear dx by subtracting edx with itself. As you can see, it has a number of 128. We will step over this, and edx has become 0. Now we set the divider to 4 in the data by moving cx. So, as you can see, cx is now 0. Now we're setting the ECX to 4 to divide with AX. Now we will step over it. Now it has become 4. Then we need to store the result into AX. Basically, to divide our variable. Now we have thus divided AX with AEX and ECX with 4, thus having our result, which is 10,240. Now the location has been pointed to the result, and we will thus printing our result in the output screen over here, which is 2,800. The print code on the line 24 is optional because Dr. Khairunizam said it will be a bonus mark if you manage to print the output. So thus I have printed the output in the output screen over here. Now we have stored the result, and thus ending our printing session, and thus ending our debugging session. And as you can see, I have stepped over it, and then the debugging has finished. Thank you very much, and have a good day.